Greetings to F3C and F3D students. It's Miss CJ here. First of all, I would like to apologize for all the technical issues that have occurred during our first tutorial session on last Friday, 14 August. Now, you might ask, why am I creating breakout rooms and stuff you in different rooms and do discussion there, yeah? And you think that you already struggle so much, and why do you still further struggle with your friends, yeah? Now, here's the thing, because first of all, we never have any face-to-face session before, and it's my first session with you. I'm not the one who did the lecture with you. I simply barge in and have a 1 hour session together with you, and there are 60 plus over of you, and it's very difficult to know problems of each and every one of you. Right, so I would like to break down different groups, and you can do your discussion with your friends, and when your friends explain certain things, you probably have a better understanding from there as well, yeah? And when I observe your discussions, I will know, alright, where things go wrong and where I should intervene and give further guides. That's why I think is good for you. But well, I'm still testing out. I'm not too sure whether this is the best way or not. So yeah, it's my learning as well. Learning which method is the best way to conduct tutorial sessions in this new normal. Yeah. Um, just want to emphasize again, my role as a tutor is to guide you to the right learning path. Most of you, I believe, would have already watched lecture sessions, yeah, provided by your lecturers. And as you learn the content from this lecture slide, you might have different understanding about what is being explained in the slide, and you might further search it in the internet or YouTube, and over there you develop your own understanding, and my role will be to clear your doubts or clear your misconception, because as you grasp information from resources out there, you might have certain misconception, and I hope to come in and clear those misunderstandings, yeah? Well, without further delay, I would like to go into the main content of this recording, yeah, because as I promised, I would provide a conclusion remark about your not performance, your work, yeah, for tutorial 1, where everyone's falls and where everyone is good in. So I would like to share those with you. Okay, so I will start explaining vector first, because there seems to be a lot of problems with vectors. So I'll start with question 5, okay? Because in question 5, many students confuse with the usage of sine theta and cos theta when calculating horizontal component of a vector and vertical component of a vector. Okay, so for example, given a vector A, right, with magnitude of 2 units and direction theta from from vertical plane. In other words, y-axis. All right. So rewrite vector A as a summation of component I and j. Right? So how do we write that vector? Okay, so first you must draw the vector out first. Okay, so based on this sentence, the vector will most probably looks like this. Okay, say this is your vector A, right? And the magnitude is 2 units. And the angle, the direction is from vertical plane, so we're going to draw this y-axis, and that will be the angle. Right. Now, how to rewrite our vector into a summation of I and j, alright? Of course, the coefficient is not going to be 1. The coefficient will be the component of ax and component of ay. Okay, so meaning to say, we can redraw this into this form, right? Because normally a vector is a summation of these two components, right? It has an ax component, it has an ay component, like that. Okay, now this ax is flexible. Okay, I need to complete the data first. So this is our data. Now this horizontal line is very flexible. You should be able to just move it up here, right? Okay, so back to your Form 3 maths. Okay, if you have a right triangle like this and you have a theta here, what is sine theta? What is sine theta? Okay, so I'll just label the side here. We have A, B, H, right? Normally it was labeled like that. H is hypotenuse. Okay, so sine theta is opposite and hypotenuse, right? Division of opposite, is a opposite and hypotenuse. Cos is a division of the side and the hypotenuse, B and H. So therefore, the A, right? Well, we want to look for AX, right? So A is H sine theta, and B is H cos theta. So that's how the horizontal component was formed. So AX equal to the magnitude of A, okay, sine theta in this case. For this triangle, it will be sine theta. Now, if your angle is some other position, like for example, it could be somewhere there at some point, then it will be, your horizontal component will have a cos theta. So that's how student confused, I think. Right? So I hope this will clear things up. Well, eventually A will be magnitude of A sine theta. For this case only, for this case only. So I hope with this understanding you'll be able to answer question 5. Okay. right? This is just an example, it's not really question 5. Okay, next we go into the free body diagram. I'm not sure at this point you all already know about free body diagram, but as I go through your solution for LU1, only one or two of you managed to sketch free body diagram. Alright, so what is this thing actually? Okay, so basically a free body diagram is a diagram consisting with dots and arrow. So for example, it might look like this. Wait, okay, and perhaps if you know this object is not moving, it must have been balanced by some other type of force. So that's another balance, so normal force, or it could be just tension or anything, right? But at the moment I'll just name it normal force. So this is just an example of a simple free body diagram. Alright, now in question number 12, right, there's a diagram, a frame writing I love physics, okay, and it was hanging on a string or something like that, right? So maybe if you are still new with free body diagram, just sketch that photo frame out, okay? It doesn't have to be so beautiful, okay? I love physics, okay? Alright, I know it looks sucks. Now it has a weight component, okay? And you know that there is tensions hanging this photo frame, okay? Tension force T1, T2. Since I already write a vector notation there, might as well I add vector notation up here as well, okay? Well, two ways to go about with this. If you want to straight away have your horizontal and vertical component, go ahead, right? Up to you. But some international texts, they don't include that horizontal and vertical. They just write the raw force that is balancing this photo frame. Okay, so now, as I say just now, free body diagram, you just need a dot, right? We don't need something so big in the middle. So we will replace this with a dot, okay? And the essential force that's pulling this particular object, all right? T1, T2, and the weight, okay? So this weight is balanced by these two. That's why it stays there statically, doesn't move. If it's moved, still you just have to make sure all the component of vectors that is acting on that object is drawn, all right? That's free body diagram, okay? So like I say, if you want to put in the vertical component and horizontal component in this diagram, yeah, is you can do that, right? So T1y, you have T2y as well, and then here will be T1x, and you have T2x, yeah, in this direction, okay? And some of you might not be aware, so this component will automatically be a negative, will have a negative value, right? So if you try to balance the horizontal component, say example, okay, so directly you just write negative T1s minus T1s. This represents the direction, okay? And then T2x is to the right, so it's plus, okay, T2x, right? And vertical component will be, yeah, Going down will be negative, so negative W. And you have going up two components, so 2 plus. One is T1y, one is T2y. Right? So that's how you write the horizontal component and vertical component of this free body diagram. Alright, now I will go to question 7. Right? So I think most of you focus on the diagram too much. Yeah. So you are confused in how to get about solving the questions. My approach will be to look at the stories again. Right? Question 7. The story says you have a hiker. Right? This hiker is walking or already walks. Yeah. 2.5 kilometer with direction 53.1 degree. Oh, sorry. So north of east. Okay. So without the diagram, most probably you will not know what is north of east. That's why the diagram is there. Okay. But don't get confused by the diagram itself because of too much information. Right. So this is the first walk that he took. Right. Next, what happened is the hiker continue to walk. Okay. How does he walk? They say it's due to east, right? So in this distance, 2 kilometer. Okay. So without that diagram, and I sort of know 53.1 degree, so your diagram will now looks like this. Let me have my y-axis and the x-axis here. Okay. So at first the hiker is at 0. Okay. First the hiker is at 0, and the hiker walks in the direction 53.1 north of east, right? Based on the diagram given in the questions, that 53.1 is an angle from x-axis. So the hikers actually turn this direction. So he slowly walks as far as 2.5 kilometer. Okay, and he stops. Okay, he stops there. Okay, so if he doesn't continue to walk, this vector is the displacement, right? Or rather, this distance is the displacement, right? First displacement. Okay, but of course, if you walk a few more times, that summation is not going to be your total displacement, because that's not how you calculate. Anyway, back to this. This is first displacement if he could stop there and doesn't move anymore. All right. I mean, displacement is always the subtraction, of these two coordinates, right? Never mind, out of topic already. So first displacement is like that. Now second, we go to the second one. Continue to walk due to east. So at this position, hiker continue to walk in horizontal position. So at first like that, next it was like that. Okay, for 2 kilometer, and that's the final destination. So okay, forget about this one because we're not looking at this. I'm just trying to highlight the idea of the displacement. Okay, now the question asks, what is the resultant displacement? Okay, so don't get frustrated with this word resultant. Okay, it just means the final thing or the net thing. Okay, net result, the net displacement, or final thing, all right? Something as a result, right? That's the word resultant. It's just English, you can look up in dictionary. So anyway, now that's the final destination, and we want to find displacement. And now how do you find displacement? How do you find? So where's displacement now? So that will be our displacement, isn't it? Okay, this is our resultant displacement, right? Of course, like I say, you don't sum like that. That's not displacement. that's a tracing already, right? That's tracing, not displacement. Displacement is always counting the final destination from the initial point. Okay, so that's displacement. So if you draw, so that's why the diagram in your question draw a vector C, right? So okay, this look very messy already. So I'm just going to redraw that C out here. This is C, right? C is a summation of the what I call tracing just now, right? So it's a summation of A and B, okay? Oh, okay, a bit out of ratio. A is supposed to be longer. I'm sorry. Okay, now back to this. So the basic of vectors will give you an idea that C is actually a summation of vector A and vector B. Okay, so vector A will have its own AX component and its own AY component, or rather the I component and J component. This is for A. And for B, it will have its own horizontal component and vertical component. Okay, so if you want to find resultant displacement, what do? You just have to sum this, right? This will be your CX and that will be your CY. Okay, so I won't go to the final step. I hope you will finish that on your own. Here are some of the solutions that I managed to collect from our breakout rooms. First is this question 4, shared by Muhammad Haswan. So this calculation itself is considered okay, no problem. However, it could be improved by adding a diagram showing the horizontal components and also vertical components. Here I would like to share a screenshot from Muhammad Noor Safaruddin's. He did these solutions and almost perfect, except at one point when he substituted the dot product, the dot is missing. So that dot has to be there, and we cannot assume that people knows. Yeah. Okay, this is solution for question 11, shared from Dayang Nor Sharina. Also almost perfect, like question 6, and same problem, the dot is missing after substituted for evaluation of dot product. Okay, so hopefully this mistake is not repeated again. Alright, this is question 13, shared by Amira Christian. The solution also has something to be added on, which is in part B, where the unit is not written, right? Even though this magnitude might not have centimeter, meter, or kilometer or anything, but just write unit there, UNIT, to indicate that the actual unit is not mentioned. Here's a solution for question 8. I find this solution is the best because in the first part, it really highlights the difference between systematic errors and random errors. And the second part about this answer will be the volume. The volume is simplified until the correct significant figure, which is required by the question. Now, how do you select the correct significant figure? Now, to choose the correct significant figure, you have to look at the values provided in the questions to calculate the volume. So in this case, there are 3 different values because of 3 dimension. So from these 3 values, the value with the shortest significant figure is 4.8 cm, and that is 2 significant figure. So which is why the final answer should be also 2 significant figures. Okay, I'm going to explain about question 19. Again, I won't be touching on the question 19 itself, but I just want to highlight that there seems to be a lot of misunderstanding or misconception about balancing dimension of terms in a formula or in an equation. For example, let me give you a situations that you normally meet. Situation 1. This situation is what we call single term equation. Means at the left hand side you have one term only, and on the other side you will have another term, one term only. You don't see any summations or any division or any of sort. So for example, given acceleration A, right, equal to velocity v divided by time, right? That's the formula that you typically knows. And say we just first encounter this and we want to satisfy ourselves answering these equations that are actually dimensionally balanced or dimensionally correct. So what happens is you will rewrite this equation. You rewrite the formula above with the dimension form, in a dimension form, right? That's the dimension form. Okay, so you must use the correct bracket. Okay, so for A, the equivalent dimension terms will be LT power -2 equal to, for V will be LT minus 1 and divided by T. Okay, this could be rewritten as LT -1 multiply T power -1 as well, right? So that is easier for you to evaluate. And very simple, we can see that both sides looks exactly the same. So, and you can observe that L has power 1, so balance. T has power -2, right? So that's why we say this equation is dimensionally balanced or correct, right? Whichever way you name it. Okay. Okay, in situation 2, we will have equation involving summation of terms. Okay, so say for example, okay, this formula U equal to V plus AT, right? This formula you are very familiar in LU2. So we're going to just study the dimension. All right, we're going to study the dimension. So U is LT -1, right? V is LT -1. A is LT -2, and T is just T. So when you reach here, your job finished already, supposedly, right? You don't have to write like this, right? No need, because we don't want to do summation of quantity, yeah, in dimension analysis. Okay, in dimension analysis, what we are interested is only whether it is balanced or not for every single term, right? It is important that these two terms that you want to sum up has the same exponent in each different in each different type of length or unit that you want to study. Okay, so that's all, right? Once you find out that it is dimensionally balanced or correct, good enough. Okay. Okay, so we back to our actual question 19. All right, in the question, they actually give you an established equation, right? Given an established equation, right? Meaning to say, if the equation has a summation of terms, it's supposed to be dimensionally balanced, all right? Meaning to say, you only need to check the dimension for term P and also the term AV, right? The B you can ignore. So we're just going to write like this for question 19, okay? So given an established equation, we only need to focus on P and AV, right? Even though A is unknown constant, but it has a unit, right? It might have unit, and it's not dimensionless. Yeah, it's not dimensionless. So might be not dimensionless. Now you might ask, what is dimensionless? Okay, so this idea is also very important, okay, especially for question 2, because in question 2 you have terms involving ln, right? There's a ln and a division of two different quantity. Okay, this ln doesn't have a unit. Okay, it doesn't have a unit. Right, especially when the quantity in here has already been divided. Okay, so it doesn't have a unit. Okay, so a term when it doesn't have any unit, it is what we call dimensionless. Yeah, no dimension, right? So anyway, so once you compare like this, then you'll be able to find the dimension for your A, right? Or your unit for your A. Okay, now back to this ln term or rather a natural. This is actually a natural logarithmic term, logarit or logarithmatum. Okay, but if we want to mention a term, something, we just add an adjective here. English. All right, anyway, in question 2 it was highlighted that this is a ln ND, ln NA. And if you search in Google, actually they say every logarithmic term is dimensionless. All right, again, what does dimensionless means? Okay, you're not going to get any dimension, right? No dimension. Okay, talking about dimensionless, maybe I want to highlight question 2, because in question 2 you will come across as you simplify, okay, simplify the dimension. So what happened is you will encounter a situations where right, okay, so actually, like I say in previous example, you should not, there's no need to simplify until this stage actually. Okay, there is an earlier step where you can just stop there. Okay, so I just copy down the last term that you will come across as you simplify the dimension. Okay, actually when you write like this also it feels weird. It's like dimensionless equal to -1 or just negative dimensionless or something like that. As I emphasize here, well, in dimension analysis, okay, what matters the most is dimensionally balance. We only care about the dimension. We don't have to pay too much attention with the sign. Okay, no need pay attention. And we don't have to highlight this equation, so there's no need to write this. Okay, if you want to make your solution looks logical, you can just in the first step says since the left hand side term is logarithmic, therefore right hand side will be dimensionless as well. Okay, so you start your solution like that. Okay, and you start to just simplify the right hand side. Okay, so you just copy out what's your right hand side and you simplify and you reach to this stage, and then you just say, okay, well, whatever I wrote here I just prove. Okay, I just prove this is dimensionless.